So section 1.5 is on quadratic equations. So a quadratic equation in X is an equation that can be written in the general form of ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. A quadratic equation is also called a second-degree polynomial equation. So we have learned numerous ways of solving these back in intermediate algebra. The first one is by factoring. So if a quadratic equation has 0 on one side and a factored expression on the other side, it can be solved using the Zeroproduct Principle. And so the Zeroproduct Principle says that if we have AB is equal to 0, then either A is 0, or B is 0, or both of these are 0. So once we have factored and we set it equal to 0, we want to set each individual factor equal to 0 and solve each resulting equation for x. So for example, x minus 5 times x minus 2 equals 0. I want to set x minus 5 equal to 0 or x minus 2 equals to 0, and then solve, and we get x equals 5 and x equals 2. So to solve a quadratic equation by factoring, if necessary, rewrite the equation in the general form of ax squared plus bx plus c is equal to 0, moving all non-zero terms to one side, thereby obtaining 0 on the other. Then you factor completely. You apply the Zeroproduct Principle, setting each factor containing a variable equal to 0. You want to solve the equations in step 3, and then check the solutions in the original equation. So let's try this with example 1a. So first, we want to make sure it's set equal to 0. So since we have that, we can start by factoring the left-hand side. So we have 4x squared minus 2x equals 0. We always look for a greatest common factor first. So we can take a 2x out of both 4x squared and negative 2x. So let's factor that out. And so what we have left over is 2x minus 1 is equal to 0. 2x is simplified and 2x minus 1 is also simplified. So we just want to make sure that we set both pieces equal to 0. So we have 2x equals 0, and we've got 2x minus 1 equals 0. And our last step is to just solve both of these equations. So to solve for the first one, we divide both sides by 2. So what we end up with is just that x is equal to 0. And now we want to do the same thing for 2x minus 1 equals 0. We want to add 1 to both sides. So we have 2x equals 1. And then getting x by itself, we'll divide by 2 on both sides. And we get that x is equal to 1/2. So we have two solutions. We have x equals 0 and we have x is equal to 1/2. Now go ahead and try to attempt 1b on your own. Alright, so let's try to solve for this one. First thing is it's not set equal to 0. So we need to subtract 4 from both sides. So we have 2x squared plus 7x minus 4 equals 0. Okay, so now that it's set equal to 0, we want to factor the left-hand side. Everybody does this differently. If you've taken my class before, you've learned the Berry method. I don't care how you factor as long as you do it correctly. So I'll show you how I do it in my class. So what you want to do is you're going to see if you can take out a greatest common factor. In this case, we have a 2, a 7, and a 4. So nothing can be taken out of all three of these terms. Next, we go on and we take A times C, or 2 times negative 4. Which is negative 8. We want to find the factors of 8. So we've got 1 and 8, and 2 and 4. Now because AC is a negative 8, that means I need to have one positive term and one negative term. From these two factors of 1 and 8 and 2 and 4, we have to find the combination that adds up to B, which is 7. So in this case, if I have a negative 1 plus an 8, I'm going to get 7, which is B. So once I have found my combo, I want to bring the leading coefficient down into both sets of parentheses and split my x. So 2 has to come down into both. And then in my blank spots, I add in those two terms that I just found to the right. And my last step for this method is to divide out anything they have in common. So between a 2 and a negative 1, they only have a 1 in common. And between a 2 and an 8, they have a 2 in common. So what I have is 2x minus 1, and I have x plus 4 is equal to 0. So the left-hand side is completely factored. Now I want to set each piece equal to 0 and solve. So I have 2x minus 1 equals 0, and I have x plus 4 is equal to 0. So adding 1 to both sides, we get that 2x equals 1. Divide by 2, and we have that x is equal to 1/2. For the other piece, all we're going to do is subtract 4 from both sides. And we get that x is equal to negative 4. So our two solutions are negative 4 and positive 1/2. Now let's talk about a different method, the square root property. So if we have a quadratic equation that's in the form of u squared is equal to d, where u is an algebraic expression and d is a non-zero real number, we can use the square root property to solve it. So if u squared is equal to d, then u is equal to the square root of d, or u is equal to the negative square root of d. We can also write this as plus or minus square root of d. Before you can apply the square root property, a squared expression must be isolated on one side of the equation. So let's try this with example 2. We want to solve by the square root property. We need to have the squared piece completely by itself on one side. So our squared piece is the x squared portion. So that needs to be completely by itself on the left-hand side before we can take the square root. So the first thing we can do is we can subtract 25. So we have 9x squared equals negative 25. That x squared piece still isn't by itself, so we need to divide by 9 on both sides. So our 9's cancel on the left, and we have x squared equals negative 25 over 9. And so our squared portion is by itself. So we can take the square root of both sides, and we get that x is equal to plus or minus, that's very important when we talk about the square root property, of negative 25 over 9. Now we can simplify this a little bit. So we know that a negative underneath the square root can be pulled out as an I. So we have x equals plus or minus I times the square root of 25 over 9. And by the quotient rule, we can split a square root with the fraction into a square root on the top divided by a square root on the bottom. So this becomes plus or minus I square root of 25 divided by the square root of 9. And these are both perfect squares, so they'll simplify nicely. So our final answer is x equals plus or minus 5 over 3 I. Now you guys try for example 2b. Alright, so we have x minus 2 squared is equal to 6. So x minus 2 is our squared expression, and it's already isolated by itself, so we can go ahead and take the square root of both sides. So we have x minus 2 is equal to plus or minus the square root of 6. Well, solving for x, all we have to do is add 2 to both sides. Now be very careful. We can't add the 2 and 6 together because they're not under square roots. So the square root of 6 is completely by itself, and 2 is not a square root, so we can't combine these. So what we end up with is x equals 2 plus or minus the square root of 6. So for another method, we have completing the square. This tends to be the one that most students dislike the most. So if we have an equation in the form of ax squared plus bx plus c equals 0, but it can't be factored, we can convert it to an equivalent equation that can be solved using the square root property. And so this is accomplished by completing the square. So if x squared plus bx is a binomial, then by adding b over 2 squared to both sides, we will get a perfect square trinomial. And so the way we want to complete the square is first the leading coefficient must be 1. So if it's not, you need to divide both sides by a. Then you isolate the variable terms on one side of the equation and the constant term on the other side. So on one side you only want to have an x squared and an x term, and on the opposite you want to have your constant. Then you want to complete the square. So you're going to add the square of half of the coefficient of x to both sides of the equation, or b over 2 squared. That's where this comes in. And then factor the resulting perfect square trinomial. Then you'll use the square root property and solve for x. So let's go ahead and try this with example 3a. So solve by completing the square. First, we always want to make sure that the x squared term has a coefficient of 1, which in this case it does, so we're good to move on. Next, you want to have just x squared and the x term by itself on the left and have the constant on the right. So we need to move the 4 to the other side. So we have x squared minus 6x equals -4. And then we're going to add our b over 2 squared term to both sides. So let's figure out what that's going to be. Let's figure out b over 2 squared. Well, our b in this case is -6. Well, -6 divided by 2 is -3. And -3 squared is 9. So what we're going to add to both sides is going to be 9. So let's go ahead and add that to both sides. We've got x squared minus 6x plus 9 is equal to -4 plus 9. What I do to one side, I have to do to the other. So let's simplify the right-hand side a little bit. So we have our x squared minus 6x plus 9. And that's going to be equal to 5. Now the reason why we do this is because the left-hand side is now a perfect square trinomial. And the best part is you don't even have to think about how it factors because we've already figured out the form of it. So we know it's going to be x, a blank, and it's squared is equal to our 5. And the term that goes in here is actually the term that you found before squaring it. So in this case is -3. So what we have is x minus 3 squared is equal to 5. Now we have something squared is equal to a number, so we can use the square root property. So we get x minus 3 equals plus or minus the square root of 5. We want to add 3 to both sides. So we have x is equal to 3 plus or minus the square root of 5. And that is our final answer. Now I want you to pause the video and attempt B on your own. Just remember that you always need to have a coefficient of 1 on the x squared term before you can start moving things around. Alright, so let's try this one on our own. So, we have 9x squared. That's the first problem. So we need to divide every single term by 9. So we have x squared minus 6 over 9, which is really 2/3, minus 4 over 9 equals 0. So now we have our coefficient of 1 with the x squared term. Now we want to have our x squared and our x's by themselves. So this term and this term need to be by themselves, so we need to add 4/9 to both sides. So we have x squared minus 2/3 x is equal to 4/9. We need to figure out that b over 2 squared term that's going to be added to both sides. So let's go ahead and figure that out. So b over 2 squared, well, that's negative 2/3 over 2 squared. We use the rule of keep, change, flip when we have a fraction inside of a fraction. So this is keep the top, negative 2/3. Change that division to multiplication and flip the bottom piece. So we have times 1/2, and then we're going to square it. Well, when we multiply across the top, we have negative 2, and when we multiply across the bottom, we have 6. But negative 2 over 6 is negative 1/3 squared. And we can square the top piece and square the bottom piece, and we get 1 over 9. So we're going to add 1/9 to both sides. So x squared minus 2/3 x plus 1/9 equals 4/9 plus 1/9. We can simplify the right-hand side by adding 4/9 plus 1/9. So we have x squared minus 2/3 x plus 1/9 equals 5 over 9. The left-hand side simplifies into a nice piece that's squared. And remember, it's always the piece before we square it. So negative 1/3 in this case. So this factors as x minus 1/3 squared is equal to 5 over 9. We can take the square root of both sides. So we have x minus 1/3 is equal to plus or minus, and I'm going to split my square root into both pieces, so square root of 5 over the square root of 9. But this is just plus or minus the square root of 5 over 3. And we want to add the 1/3 to both sides. And so our final answer, going to come over here to the left, is x is equal to 1/3 plus or minus the square root of 5 over 3. And we can actually combine this into a single fraction. And we get 1 plus or minus the square root of 5 all over 3. All right, and the last method for solving is the quadratic formula. This is the only thing in algebra that works for every single quadratic equation. We don't have this tool for many things in mathematics, so it's exciting to be able to have this in our back pocket if we need to use it. So the quadratic formula first needs to be set equal to 0 before you can use it, but it is x is equal to negative b plus or minus the square root of b squared minus 4ac, and this whole thing is divided by 2a. Now this is a super important formula. So you want to memorize this as soon as possible so you can use it whenever you're solving if you get stuck. So let's use the quadratic formula to solve the following equation. We have 8x squared plus 2x minus 1 is equal to 0. So let's label A, B, and C first. We have A is equal to 8, B is 2, and C is -1. So now plugging into the formula, we have x equals -2 plus or minus the square root of 2 squared minus 4 times 8 times -1, and that whole thing is divided by 2 times 8. Well, let's simplify a little bit. We've got -2 plus or minus the square root. 2 squared is 4, and we have -4 times 8 times -1, so we end up with plus 32 all over 16. Simplify the inside of the radical a little bit. We have the square root of 36 all over 16. Well, the square root of 36 is a perfect square of 6. So we have -2 plus or minus 6 all over 16. And so let's split this into two separate fractions so we can solve this nicely. We have x equals -2 minus 6 over 16. Well, this is -8 over 16, or we have -1/2. We also have x is equal to -2 plus 6 over 16, but this is 4 over 16, which is 1/4. So our two solutions are x equals -1/2 and x is equal to 1/4. Now go ahead and pause the video and attempt B for yourself. Alright, so for part B, we have that A is equal to 2, B is equal to -6, and C is equal to 1. So we have x is equal to -6 plus or minus the square root of -6 squared minus 4 times 2 times 1. And this whole thing is divided by 2 times 2. So let's simplify a little bit. -6 gives us a +6, plus or minus the square root. -6 squared is 36. And -4 times 2 times 1 is just -8. All over 4. Well, 36 minus 8 gives me plus or minus the square root of 28 all over 4. Now 28 is not a perfect square, but we can simplify it down a little bit. So I'm going to use my tree method. So this breaks down into 4 and 7, and 7's prime. So we've got 2 and 2. So my pair of 2's gets pulled out, and my 7 will stay underneath. So I've got 6 plus or minus 2, square root of 7, all over 4. And the last thing I can do is ask myself, what goes into 6, 2, and 4? So 2 can be taken out of all three of those terms. And so we end up with 6 divided by 2 is 3. 2 divided by 2 is just a 1, so square root of 7. And 4 divided by 2 is 2. So our final answer is 3 plus or minus the square root of 7 all over 2. And let's try the last one. Go ahead and pause the video and attempt it on your own. Alright, so let's go ahead and try this one. Let's label our variables. We have A is 3, B is -2, and C is 4. So we have x equals -2 plus or minus the square root of -2 squared minus 4 times 3 times 4. And this whole thing is all over 2 times 3. Alright, we just want to do a little bit more simplification. You can see a lot of repetitiveness going on here. So we have -2 or +2 plus or minus the square root. -2 squared is 4. -4 times 3 times 4 is -48. And this is all over 6. Well, 4 minus 48 gives me plus or minus the square root of -44. And this is all over 6. We know that a negative underneath a square root can be pulled out as an I. So we have 2 plus or minus I, square root of 44, all over 6. And let's break down this 44. Well, this is 4 and 11. 11's prime, but 4 is 2 and 2. So our 2's are going to get pulled out, and the 11 will stay underneath. So we have 2 plus or minus 2i, square root of 11, all over 6. And same as the last one, between a 2, and a 6, I can pull a 2 out of all 3 of those pieces. And so we get 1 plus or minus I, square root of 11, all over 3. And that's our final answer. Now we're going to talk about the discriminant. And the discriminant is actually just the quantity b squared minus 4ac, which appears under the radical sign in the quadratic formula. And so this doesn't tell you what the solutions are, it just tells you what the solutions will look like. So if the discriminant is greater than 0, that means we'll have 2 unequal real solutions, or 2 distinct solutions. This means that you end up having 2 x-intercepts on your graph. If your discriminant is equal to 0, you will have 1 solution, which is a repeated solution, or you'll have 1 x-intercept. If your discriminant is less than 0, that means you have 2 imaginary solutions, so 2 solutions that have the imaginary unit I involved, and you will have no x-intercepts when you graph it. So we just want to compute the discriminant and then determine the number and the type of solutions. So let's apply this to example 5a. And so just like with the quadratic formula, it has to be set equal to 0 to use it. So our A is 3, our B is 4, and C is -5. And so plugging into b squared minus 4ac, we have 4 squared minus 4 times 3 times negative 5. But that's 16. And negative 4 times 3 times negative 5 is plus 60. And so we end up getting 76. So since this is greater than 0, that means that we will have two unequal real solutions. Alright, go ahead and pause the video and try the second piece. So for the second one, we have A is equal to 9, B is equal to negative 6, and C is 1. So B squared minus 4AC. We've got negative 6 squared minus 4 times 9 times 1. Well, this is just 36. And negative 4 times 9 times 1 is also negative 36. And 36 minus 36 is 0. And this means that you're going to have 1, and it's a repeated solution. That's a real number. Go ahead and pause the video and try C. Alright, so for part C, we have A is 3, B is negative 8, and C is 7. So B squared minus 4AC. We have negative 8 squared minus 4 times 3 times 7. Well, this is just 64. And negative 4 times 3 times 7 is negative 84. And 64 minus 84 is negative 20. And since this is less than 0, that means we'll have no real solution. And it'll be two imaginary solutions. So it doesn't tell you what the solutions are, it just tells you what they look like. Alright, so let's just do one more problem, and it's an application problem, which is everybody's favorite. I know we love word problems. So we are going to talk about a right triangle and the Pythagorean theorem first. So a right triangle is a triangle with one angle, which is measuring 90 degrees. The side opposite of the 90-degree angle is called the hypotenuse, which is the longest side, and the two other sides are called legs. You've probably heard this formula 1,000 times before, but the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse, which is the longest, and a and b are both your lengths of your legs. So let's use this concept when we're talking about the size of a television screen. Alright, so for example 6, did you know that the size of a television screen refers to the length of its diagonal? So if the length of the HD TV screen is 28 inches and its width is 15.7, what is the size of the screen to the nearest inch? So we know the length and the width, and we want to find the diagonal. So let's draw a picture first. Pictures help a lot of times in word problems so that we can visualize what we're actually solving for. So we have a TV, and we'll be looking for the diagonal across. We know that the length is 28 inches, and we know that the width is 15.7 inches. And we want to solve for x. Or we can use c in this case because we're talking about the Pythagorean theorem. Alright, so using our Pythagorean theorem, we know that a squared plus b squared equals c squared. A and b don't matter as long as it's the two legs. So we have 28 squared plus 15.7 squared is equal to c squared. Well, 28 squared is 784. And 15.7 squared is 246.49. And that's equal to c squared. Adding these together, we have 1030.49 equals c squared. And we want to take the square root of both sides, so we just get c by itself. So c is equal to plus or minus the square root of 1030.49, or c equals plus or minus. Let's round to the nearest whole number, so we'll go with about 32. Now one of these we can get rid of, and so since we're talking about dimension, which is length, we have to have a positive number. So c, or the size of our television, must be 32 inches.